Better Buildings for Humans is powered by Advanced Glazings, makers of the Solera line of products. Solera is the leading glass glazing made specifically for architectural daylighting and with extreme insulation performance. Learn more at advancedglazings.com. Hello, and welcome to this week's episode of Better Buildings for Humans. I'm your host, Joe Menchefski, and this is the podcast where we take a look at the impact that the built environment has on our health, our wellness, our productivity, and our just general joy of being alive. And of course, we always have to talk about sustainability as well. Today, I'm really excited because I always love the episodes where we dive in and talk a little bit about, specific practices, practice leaders. And I've got a really cool one today. I've got Scott Gustafson from Harley, Ellis, Devereaux from the Detroit office. Scott, it's wonderful to have you. Thank you so much for joining us today.
Thank you. I'm really excited to be here.
Yeah, I know. This is going to be great. First of all, before we do anything else, I just saw something pop up on LinkedIn fairly recently that you're receiving an award for AIA Michigan's Young Architect Award. Is that correct? Did I get that right?
Yes, that is correct. I'm not as young as other recipients, but this award is given to people who are in the first 10 years of their licensure for service to the profession. I had the opportunity to serve on the Michigan State Board of Architects for 3 years. As the vice president and the president, I was on the state board of our local chapter of the AIA Huron Valley near Ann Arbor. As vice president, and past president, I've served on the planning commission and the zoning board of appeals in my township. And all of these are opportunities that are available because I'm a licensed architect. And so it was important to me to get involved in things in my community as soon as possible.
Well, congratulations. And on behalf of your community, thank you. Thank you for your service. That's absolutely wonderful. Now, let's get to know a little bit more about you. First of all, tell us why you chose architecture as a career, and then tell us about the pathway that led you to become, a design leader in science and advanced manufacturing with HED.
Sure. As I remember back, I think I made the decision that I wanted to be an architect in fourth grade, around 10 years old. My uncle, my mom's brother, is an architect, and it was maybe around that time that his family moved back to the Chicago area where I grew up. And so I would go to his office and see projects he was working on. He would take me to construction sites. And I think maybe it was just something about his personality and that work that seemed really appealing to me. And so I just decided I want to be an architect. He gave me an old drafting table that I set up in our basement, and I would draw, elevations of little houses. And I was very fortunate in high school. I didn't go exactly to a technical high school, but we had a lot of technical classes you could take. So I had 4 semesters of architectural drafting in high school. I did 1 semester of engineering drafting, which I think I used AutoCAD version 6 in the early 90s. And at that time, I thought I knew a thing or two about architecture, having taken these drafting classes and applied to go to architecture school and was accepted at Kansas State University. And when I got there, I realized architecture was not what I thought it was, but I really liked it. And spent 5 years in school at Kansas State and graduated and thought, all right, now I know what architecture is about. Went out, got my first job. My then girlfriend and I moved to Tucson, Arizona, because we thought the desert seemed like a nice place to work. And there were still are many great architects practicing in the Sonoran Desert, doing very interesting place-specific architecture. Did not get a job with one of those highly sought after firms, but, worked for a couple of really good local practices. And, once again, I thought I knew what architecture was about, and getting into the profession, was something completely different. I spent about 5 years living in Tucson and working there. And eventually I felt like I wanted to try something a little bit different. So I moved to Los Angeles, California, worked for a couple of small firms there for a few years. And then I spent some time in Colorado, a few years there, and then moved back to California and stayed for another 7 years. So 10 years total in LA. And then about 8 years ago, I moved to Michigan. And I've been here in the Metro Detroit area ever since. I think sometimes I feel like maybe I moved around a little bit too much in my career. But I also now think that having had the opportunity to work in different size firms, firms with different kinds of practice, some high design, more service, some are more service firms working on big budgets, little budgets, working in the hot desert, working in the temperate climate of Southern California, working in the snows of Colorado, has given me a wide exposure to be able to work on many different types of projects because I have this diverse background.
Yeah, oh, absolutely. Yeah, I think that's wonderful. I've certainly built my career that way with a whole lot of different angles and different views. And yeah, there's times when I've felt really weird about it, but in the end, I feel a lot better for having, that sort of broad background. And it just suits my personality better. And clearly, it does the same for you. I have to ask you a couple more things about yourself that I discovered. Your work as a teacher. Can you tell us a little bit about what you're doing as a teacher? I think it's part-time.
Yeah, I'm an adjunct faculty at a school called Lawrence Technological University that's right outside Detroit. It's a private research-based school, and I'm in the College of Architecture. The studio that I teach is called Comprehensive Design. And so it's like a mini introduction to designing a project in a more detailed way than you normally get in an architecture school. So our students, of course, do the layout and the design of the building, but they're do a deep dive into structural systems and how structure and architecture and space can work together. They do energy analysis, so daylighting analysis, spatial daylight autonomy. We do energy generation potential, whether that's through PV or wind. They look at the energy use intensity of their project and try and understand the formal moves they're making, the shape of the building and the placement of windows, how that affects energy and daylight. And they need to do some landscape architecture, site development as well. So giving them an introduction to the multiple factors that play into designing a holistic building and using software and metrics to understand the consequences of some of their design decisions that either improve energy performance or hinder it. And so that's a really fun project or really fun studio to be a part of to help students kind of understand the multifaceted way buildings get designed and how that leads to high performance buildings.
Right on. And one more thing that caught my eye, and that was, from what I understand, you've got some connection. I'm assuming that last name is part of it, but you've got some connections to Nordic countries. Can you tell us a little bit about what you're doing there and how those connections work?
Yes, part of my family background on my father's side is from Sweden, and I have been for a long time interested in mid-century Scandinavian architecture, things from Denmark, Sweden, Norway, Finland, and as a way to dive a little bit deeper into the culture that made that kind of mid-century architecture more humane and more nuanced than maybe what we think of as like corporate modernism in the United States. I've been studying Swedish, the Swedish language, and also Danish and a little bit of Norwegian. They're all kind of tied together. And this has helped me be able to read books and articles in those source languages, things that maybe would not be readily available in English, to be able to, study the architects and the buildings that really inspire me in a deeper way. I'm also a member of the Swedish Association of Architects, Sveriges Arkitekter, and the Danish Association of Architects. And so I get professional resources through those organizations that, again, help me with my Scandinavian architecture research. And I try and bring those things that I learn or the aspects of those buildings that inspire me that really tie into human health and well-being and cozy spaces and try and use that to influence the projects I design here at HED.
I want to schedule you back in for a second interview. Hopefully you'll be willing to do that after this is over, but I think we could do a whole episode talking about Scandinavian architecture. So let's talk about that a little bit later.
Okay.
For real, I really want to do that. But for now, let's dive in and let's talk about your role as a design leader for science. Exactly what kind of buildings are you designing in this sector and for whom?
Sure. So our HED, we call the sector science and advanced manufacturing. And so that can be for life science type clients. It would be on the science side. It can be some advanced laboratory projects. The manufacturing side, it's a whole range of clients. People, sometimes automotive manufacturing, sometimes appliance manufacturing. I've got projects for a company making electrical equipment, transformers, just a wide variety of companies, some names you've heard of, some names you haven't heard of. And my role is both as the designer and the technical architect is to kind of see a project through from beginning to end and working with the client to get all the detailed technical information from their internal stakeholders, whether they're chemical engineers or process engineers or their equipment suppliers who have very tight tolerances and specific requirements for the placement of their manufacturing equipment, pulling all of that information together and helping the client work with their layout to build the kinds of factories and facilities they need.
If it's plastic, it's a problem. Solarowall, the only translucent glass system in the world. For glaziers, it installs fast for better margins. For architects, it's a design you're proud of for years. And for owners, it's lasting performance and real return on investment. Visit advancedglazings.com to see if Solarowall is right for your next project.
Oh, fantastic. By the way, I'm a chemical engineer, a process engineer. That's my undergrad. So this is my world. That's one of the reasons I'm so excited. So let's hone in on science. Let's focus in on the science rather than the advanced manufacturing for just a second. What aspects of design are unique to this practice, Scott? Like, what are the special considerations? You sort of hinted at a couple of them there, but let's dive in a little deeper, peel back the onion a bit.
Depending on the kind of work the client intends to do in their facility, it's really custom building spaces that support their goals and needs. So it's not really a one-size-fits-all situation. It's definitely diving into the specifics of what it is they're researching and designing the lab spaces and the other support spaces to meet those goals.
So, let's talk about a lab for a second. And, there's probably scenarios where they don't want natural light in the lab because it could impact, growth rate of a particular strain of bacteria or something like that. Do you run into those sorts of details that you have to adapt to a certain amount of air turns, or it's got to be completely recirculated, remanaged air? Can you share any sort of examples of those kinds of details that impact your work?
Well, I think that, across project types, there are always limitations, whether it's mechanical or lighting or other things that might limit our flexibility, especially towards daylight and views. I also think that a lot more clients are recognizing the importance of including those features in buildings because it contributes to employee health and employee retention and general employee well-being. So maybe in a particular kind of laboratory where they're doing specialized work that needs to be in the dark, that's not going to have windows. But the other spaces in the building that the employees or researchers are going to be using are then more open to the environment and to try and take advantage of those features whenever possible.
Does it ever impact form? Like, does it ever drive form at all? Or is it more like the details, I'll call them sort of like the maintenance details?
It does affect the form because of the layout of the different spaces, whether they're labs or manufacturing areas in other types of buildings. There's certain spatial relationships that are necessary for the way different groups of employees are working with each other. Certain parts of the building might be a little bit isolated or landlocked, so to speak, but then we can wrap the common spaces or the less technical spaces in ways that have a better connection with the exterior.
Right on. Can you give me an example of how you would, have a good connection with the exterior while still meeting all the criteria you just described?
I had the opportunity a couple of years ago to work on a large manufacturing plant outside of Monterrey, Mexico.
Yeah.
And our project is in an industrial park or business park. And one of the things that was really important to our client was to create a really beautiful place that would help them with their employee retention. It's a very tight job market. There's a lot of manufacturing in this section of Mexico. And so I think people have their choice of employers. And so we put a lot of effort in outdoor spaces, in outdoor garden spaces, even recreational spaces. There were soccer field and basketball courts outside of the office area, outside of the labs, outside of the factory, but things that the employees could use, during their breaks or before or after their shifts that would make this a special place to work and be amenities that they're not going to get at the motorcycle factory down the street or, the plastic extruder up the road. Those features of the project were really important to our client to differentiate this facility from their competitors. And they're things that we were really excited to do because, as we all know, they contribute to making really beautiful places that people want to hang out in.
Well, yeah, and certainly it impacts their health, which probably drives up productivity. It probably reduces absenteeism, probably reduces turnover. I'm assuming that those are all the benefits that you're going to get from those considerations and those unique sort of, call them perks.
Yes,
Yeah.
definitely. And in that particular project, at an early stage in the design, we had the opportunity to travel to Europe to visit some of our clients' other facilities. And I noticed that many of their buildings had skylights or sawtooth roofs, to use daylighting. And so that was something that I introduced to our project in Mexico. And we worked with a sustainability consultant in Monterrey who helped us fine tune what is the appropriate roof to skylight ratio for that particular location.
Yeah.
And then as the design developed, and we got a little bit more into understanding the nature of our customers' process needs, we needed to add smoke evacuation vents to the roof. And so I had already planned a bunch of skylights, and then we were able to use smoke vents that also had basically a skylight built into them. And so
Yeah.
there I was able to solve two problems with one solution and still get natural lighting into the facility, which I think while the rest of the manufacturing area doesn't have a whole lot of windows, just that skylight gives the employees a sense of what season it is, what time of day it is, what are the changes, what's the weather going on outside, and it just enlivens the interior experience in a really interesting way.
Oh, and we all know how important those connections are, and we're learning more and more of the importance of those connections to the natural world and to the community, like every single day. So that's wonderful to hear. I'm going to go way off script for a second here, Scott. When I think of manufacturing, and I've worked in manufacturing for a pretty significant chunk of my career, the early days, probably 9 years, and I picture long, big metal buildings, very high ceilings, but like just, big old rectangles, right? Or is that always the case? Is that, the world of manufacturing, or do we occasionally see one where we can be a little bit more interesting with the form?
I would say, in my experience, they generally are long rectangles, but that's not always the case. Again, it's customizing the shape of the building and the structural module to how they're doing their manufacturing. So some production lines are in very long sequences. In this particular project in Mexico, it was more kind of like almost an S shape where things would move along the production line in the different stations. And then they were setting up multiple lines of manufacturing within the building. But other customers, where their production is in smaller footprints, you're not as limited to the standard long flat rectangle.
Right.
And a lot of my work is for customers who have either bought an existing building or are leasing an existing building. So
Right.
your ability to intervene in the roof and the facade is sometimes a little bit less than when it's a brand new custom building specific for one manufacturer and one particular type of product they're making.
So you alluded earlier to like some of the conversations that you have to have with like the techies or hardcore techies that really know their industries. And I'm sure some of those manufacturing operations, you get into some pretty unique requirements. Can you tell us a little bit about some of the engagements you've had with the techies and some of the interesting things they may have asked for?
Usually their requests are specific to whatever their particular role is in the manufacturing process or the research and development process.
Yeah.
And so, of course, we take their concerns and their needs very specific. But I think one of the roles as a designer is to say, yes, we can do that, but these are the other things that we can also do, and open up their mind to the other possibilities that good design and good architecture can bring. So they might just be focused on, like, I need a laboratory for doing chemical testing of a particular material, or this lab needs a certain number of ovens and it needs nitrogen gas and it needs oxygen and it needs to be fire
Right.
rated. And okay, but do you also want windows? Do you want to be able to see to the outside? What can we do with the lighting? What kind of lighting do you absolutely need? And, can we make sure we're paying attention to using full spectrum lighting that people enjoy working under more than just, fluorescent lamps that don't feel very good working, 40 hours a week or more under. So
Yeah.
it's really just helping them understand that there are other things that are available that don't necessarily cost more and can make the spaces more enjoyable to work in.
Yeah, the fluorescent lamps were pretty horrible. And the LED lights with, partial spectrum, we're starting to discover more and more about their shortcomings. I think about things like, really unique sort of fire suppression requirements, sort of like semi-clean rooms where you need to have positive pressure, where you need to have unique levels of filtration. Does that impact your design very much when you need to have those sorts of considerations?
Well, to be honest, I have not worked on many projects that fit in exactly in that definition, but naturally, I would say it does limit your freedom a little bit because you have just very specific environmental requirements that you need to maintain for the specific needs of that kind of laboratory.
Safety, does that have much of an impact when you're, ensuring that you're designing processes? Well, certainly the operational or the actual manufacturing process, but does the safety component come into your world very much?
Yeah, safety is always a large consideration, both in the event of a fire, making sure that we have enough exits and the travel
Right.
distance from employee workstations within the manufacturing line to those exits are within the allowable limits. And then diving deep with the chemical engineers and the process engineers to figure out what kind of materials they're using in their production. And do
Right.
those add up to the volumes that get you into hazardous occupancies? And then how do you mitigate that through architectural features like fire rated separations and sprinkler systems and other things like that? Yeah.
Right.
What I find a lot is specialists in the techies that we work with on our client side, they're super knowledgeable, often brilliant PhDs in their particular field, but they don't understand how the things they're working with get viewed from an architectural standpoint or a building code standpoint. And it's our job to make them understand why we need the information from them on the substances they're using so that we can design a facility that's safe for everyone.
Well, let's switch it a little bit towards sustainability, energy management, life cycle analysis. Like, is that coming into your world much? I'm assuming it pretty much has to. I mean, there's codes that are going to drive like effluents and stuff like that, air effluent, aqueous effluent, but just sustainability in general. Does that come in much where your clients are saying, we also want to build as green a facility as we can, given the nature of our work?
Yes, definitely. I would say, in my experience, it's our clients that are based in Europe that are usually a little bit more vocal in their interest in sustainability, whereas some of the North American clients, it's not that they don't want it, but it's not so front and center.
Right.
For some of our customers who have had bad problems with accidents in facilities in the past, they now have a prohibition on using any foam insulation. So we only use mineral wool on the walls and roof because it's non-flammable. For many of these big companies, that are public companies, they have corporate social responsibility goals that are sustainability mandates, energy mandates, human health and performance mandates. So even in manufacturing facilities that, you wouldn't normally think of as a place where sustainable design thinking would really land, it's still important to them. And a sustainable building is a building that doesn't use much energy, and a building that doesn't use much energy doesn't cost that much to run and will last for a very long time. And so the cost savings and the durability and the longevity are definitely things that interest these types of clients. And then that dovetails in with other kinds of sustainability or human wellness factors that we're always interested in.
Your buildings will outlast you, but your name will always be attached to them. Plastic, translucent walls yellow, leak, and fail in as little as 10 years, turning your design into a liability. SoleraWall is the only glass-based translucent wall system in the world, with R18 performance, glare-free daylight, and durability that matches your vision. Don't leave behind problems. Leave a legacy. Visit advancedglazings.com today.
Right on. Well, let's talk about future. Let's talk about future-proofing buildings. Like, so for example, when you're saying much of your work is adapting existing buildings to new processes, when you go into that, how much do your clients and yourself, how much do you have to think about what might come later? Or is the focus entirely on, redesigning, remodeling the building to suit the current purpose without any sort of thought to what could be next?
Well, it goes in a couple of different ways because sometimes we have clients that are moving into a building and they have plans for an initial phase of work. They're
Yeah.
going to do one manufacturing line. But then they know somewhere down the future, they're going to expand their production, and it might be another product, it might be the same product. And so even at the early phase, thinking, how are you going to grow into this building over time, over 10 or 15 years? That's an important consideration from the beginning, because you don't want to spend a bunch of the client's money doing things now that end up becoming real roadblocks to their own future use of the facility.
Right.
But I think maybe to the larger question is like, all right, if this building was a distribution warehouse before and now it's a manufacturing facility, in 20 or 30 years, can it also become workforce housing, or could it become a hotel, or could it become a nightclub? Some of those things, it's very hard to predict where they might go. But a lot of our buildings are designed intentionally, and the ones that the clients tend to buy when they're moving into an existing building are very large bay sizes, 50 by 50 foot column spacing, or my project in Mexico, our structural bay size is 24 meters by 18 meters, or about 80 feet by 60 feet. Very large spans, limiting the number of columns. And that gives a lot of flexibility in how you occupy interior spaces because of that, just the flexibility of the wide volume.
Does that make it harder to do partitioning in the future, or does it matter?
No, I don't think so.
Okay.
If you were to take a large single tenant building and you were going to partition it up into, smaller multi-tenant spaces, then there's always a reconfiguration of the sprinkler system and the electrical layout and, some of the utility distribution for different tenants. But from an architectural standpoint, it doesn't really affect how you subdivide the space very much.
Right on. Okay, let's talk about beauty. This is architecture, so let's talk about beauty. Does that come into play at all? Like, do you have, even if it's just a long rectangle, do you have the opportunity, or are you being asked to add, embellishments on the facade or in the landscaping such that this just big ordinary, horizontal monolith can actually be something that's interesting and exciting and engaging?
I would say sometimes the clients will ask for that. Other times it might be a zoning requirement of the particular location you're in. But regardless whether somebody asks for it or not, me as a designer, I'm always interested in making the interior and the exterior spaces as interesting and pleasant as possible. And I think you can do it with material, you can do it with color and texture, but probably shadows is the cheapest way to do it. So if you can give some depth to the facade, even if it's just a corrugated metal building, depending on the profiles you use and the depth of those profiles, and some variety, that can really animate the facade. Whereas, a long flat rectangle, a quarter mile long, is not going to be that interesting.
Right.
So for me, as a designer, it's always interesting to try and find those opportunities within the budget constraints of a particular project and within the material palette that's reasonable for that type of building. On our project in Mexico, we actually started the design anticipating that our facade was going to be insulated metal panels, because that's kind of what everybody does in an industrial project. And we did a lot of studies how we could enliven the facade using color. So even working within a modular 42-inch panel, what are the available colors from the manufacturer, and how can we do this in a sequence that gives the facade some gradation to make it a little bit more unique and interesting. Then through the design process, the client was more interested in, we had been talking about prefabrication of the facade and large modular elements to reduce the construction time. And so the client suggested that we start to look at mass timber. And so that kind of took the project in a whole different direction. As I mentioned earlier, in that job, the structural base spacing was 24 meters by 18 meters, or 80 feet by 60 feet. That had to be done in steel because of the size of the members and the need to run utilities through the joist space at the top. But we looked at it and eventually settled on using mass timber as our facade system because we could span quite long distances. Our 24-meter bays were broken into 6-meter sections. That also worked on the 18-meter side of the building. And so that was elements about 20 feet long. And the supplier that we worked with in Austria, they were able to do mass timber with CLT panels with insulation prefabricated in one piece. And then we had a rain screen timber facade that was prefabricated in another piece. And so basically the envelope would go up in two passes. Whereas if you were doing a traditional, insulated metal panel, that would go up pretty fast too. But if you were doing stud wall and sheathing and insulation and then some other metal or brick or some other material, it's multiple passes all the way around the building. So we also had the opportunity to leave the mass timber exposed on the inside of the factory. So we have the daylight from the skylights and the smoke vents. We have the mass timber surfaces that are, that you can see from inside the building that just give it a lot of warmth and variety and character, much more interesting than looking at the backside of precast walls or other types of more industrial materials. But, the mass timber was not an obvious choice for this building to begin with, but it's something that the client was interested in, and it solved prefabrication problems. It sped up the enclosure of the building. It had energy savings, and it was about the same cost as we were looking at for other materials.
That is, you know what? You caught me off guard completely. I was not expecting mass timber to come into this conversation in any way, shape, or form. Do you think that's going to grow? Do you think you're going to start to see more mass timber in these sort of industrial applications?
I think so, because the large format of the materials really lends itself to prefabrication and rapid installation. And I think that's something that a lot of people are interested in, is how you close in a building as quick as possible. In our particular case, because our client was European, they were familiar with some European mass timber manufacturers. That's how we got paired up. Some people think shipping mass timber to Mexico from Austria seems like a real odd choice, but apparently the carbon footprint of shipping by sea is lower than shipping by rail or shipping by truck.
Yes.
So even though it's coming a far distance, that's a little bit offset by the mode of transport. But the mass timber industry is strong in the United States and Canada, and growing more so. There's a number of manufacturers in Quebec and Ontario, British Columbia, all through the Pacific Northwest. There's factories in Illinois and down in the South, the Carolinas and Georgia. And so I think mass timber is going to be a building material that's going to grow in its use in many sectors in North America: industrial buildings, schools, hospitals, libraries. Anything that can be built quicker and cheaper and lighter. Amazingly, a mass timber building weighs less than a steel and concrete one. And it's beautiful to look at. People enjoy wood. They enjoy the texture. The feeling of being in a wood building is not like being in a gypsum board building. And I think it's an area that's only going to grow more in the future.
There is actual evidence that simply being able to see wood at your place of work or, inside of any building actually improves our mood and possibly our health as well. Like, there's actual scientific studies that show that just being able to get a glimpse of wood while we're inside is advantageous to our well-being, which is really cool. So it was interesting to hear that. It is not what I expected. And by the way, you mentioned the factories there. I had a guest on recently who mentioned that we're about to see a very large mass timber factory here in Nova Scotia. We've got lots and lots of forest available. So this is a very logical place to get into the world of mass timber. Again, you caught me off guard completely. So I'm really glad we got to that part of the discussion.
There's an interesting group in Maine that's working on wood fiber insulation. There's a lot of sawmills in the Maine area that used to sell their, sawdust and chips to the paper industry, and paper industry is fading in many parts of the world. And so this group is looking at how you can use this valuable waste material, so to speak, and give it another life. And so I think wood fiber insulation as an alternative to definitely foam insulation, but even mineral wool can be really interesting too. So there's a lot of interesting things happening in the world of wood related to buildings and engineering.
Yeah, cool. I hope we get the balance right in terms of consumption versus regrowth. That'll be another challenge at some point down the future, but hopefully I'm quite sure there are people thinking about that right now. So do you ever get involved in those sorts of conversations about, the pulp and paper industry had a reckoning on that in like the 80s where, they were consuming wood faster than it could regrow, and then they were forced to become part of mass replanting programs. Is that conversation happening with mass timber?
Definitely. I've had the opportunity to talk with foresters and forest science people from different universities in the United States about these topics. And I was at a mass timber conference in Quebec a few years ago. So hearing from people in the Canadian forestry industry, how they manage private lands, how they manage, crown lands, crown forests, and then working with European partners, how forestries are managed in Austria, Germany, Sweden, and Norway. Everybody is concerned about the longevity of the forest, and building a monoculture forest, a whole acres and acres of one type of tree. It's like a large scale cornfield. That's not very good for the environment either. So these are all really important conversations that are definitely happening, that the industry is paying attention to.
Yeah, fantastic. Okay, we are at that point in the show where I ask my $1 million question, Scott, that I'm sure you're aware of. I ask every guest to answer this question from whatever perspective they'd like. So here we go. What makes a great building?
I think a great building comes down to the scale and the materials and the spaces inside of it that really make people feel comfortable and that support our well-being and our functions. I think when I was a younger designer, especially in architecture school, I thought of buildings as objects. And maybe that's because you spend a lot of your time building little cardboard models that you look at from the outside like some kind of god. And the longer I work in this profession, I think less of a building as an object, but more as a collection of spaces that support human needs and activities. And the building is like a background. And so a great building is a building that people enjoy spending time in, that they want to spend time in, that they want to keep, and that's going to last for a long time. So this maybe goes back to my interest in Scandinavian modernism. A lot of those buildings are not particularly fancy. They're a little bit humble. They look good when they're a little bit rough. They're materials that are durable and age well. And so I'm not so much interested in architectural fads and fashion and what's hot now, because it's going to possibly look dated not too far in the future. Buildings are very expensive to build and they need to last for a long time. And so I think we need to think about them at a different time scale than a pair of jeans or a music album or other aspects of human culture that can move and change at a faster pace.
Right. Scott, that was a terrific answer. I appreciate that. All right, before we go, do you have any exciting news that you'd like to share, a big announcement, anything that you'd like to promote?
Unfortunately, at the moment, no big announcements, no big news to share, but it's been a real pleasure speaking with you and very honored to be on your show. Thank you very much.
Oh, I appreciate it. I'm so glad you could make it here. And this conversation did not disappoint. Thank you so much, Scott. You take care.
Thank you.
We hope you enjoyed this episode of Better Buildings for Humans. For more information on the world's best light diffusing and highly insulating glass glazing, please visit advancedglazings.com.